Welcome back, everybody. Today, we're diving into a topic that is absolutely essential for anyone running apps in the cloud: how to properly secure your Amazon EKS clusters. So let's grab our virtual hard hats because we're about to build a fortress in the cloud, and we're going to make sure it's secure from the ground up. So you did it. You followed all the guides, you've got your nodes humming along, your app is finally deployed. And that's a great feeling, right? But here's the question we all have to stop and ask ourselves. Is it actually secure? You see, a default EKS cluster is an amazing starting point, but it is not a fortress right out of the box. It needs some deliberate, focused effort to really harden it. And that's exactly what we're going to do in this explainer. We are going to build that fortress together, piece by piece. First, we'll talk about guarding the main gates. Then, we'll get into securing the identities of the applications running inside. After that, we'll focus on hardening the very foundation of the cluster, and we'll wrap it all up with a really practical security checklist that you can start using right away. All right, so our very first layer of defense is all about controlling access. And I'm not just talking about your developers or your ops team. This is about managing every single thing, human or machine, that needs to talk to your cluster. I want you to think of IAM as the main gatekeeper to your entire castle. Seriously. Before anyone can even get close enough to knock on the cluster's door, they have to get past this AWS guard who's checking their ID. This is your first and, honestly, your most important perimeter. If you don't have the right IAM permissions, you can't even see the cluster, let alone interact with it. Okay, so IAM lets you through the main gate. You're on the castle grounds. Now what? What can you actually do? Well, that's where RBAC comes into play. RBAC, which stands for Role-Based Access Control, is Kubernetes' own internal security system. It's like having a set of keycards that only opens certain doors. Can you list the pods? Can you delete a deployment? RBAC is what defines all of those super specific, fine-grained permissions. So you might be wondering, how do these two systems, AWS's IAM and Kubernetes RBAC, talk to each other? Well, the magic happens in this one special Kubernetes object, the AWS auth config map. This file is the bridge. It's a map that literally says, hey, this IAM role from AWS, that's allowed to act as this specific user inside Kubernetes. Getting this mapping just right is absolutely fundamental to securing your cluster's front door. Okay, so we've secured access for people, but what about the applications that are actually running inside our cluster? How do they get the permissions they need without creating a huge security hole? This, right here, is one of the most important concepts in modern cloud security. This is such a classic scenario. Your application running in a pod needs to go and read a file from an S3 bucket. How does it prove to AWS that it's allowed to do that? For years, believe it or not, developers did this in a really, really insecure way, and that's what we need to avoid. So the old, bad way of doing things was to embed long-lived AWS access keys right into your application's code or as environment variables. This is a massive security risk. I mean, if those keys ever leak, an attacker basically has a permanent key to a part of your kingdom. The modern and much more secure standard is something called IRSA, which stands for IAM Roles for Service Accounts. This method provides temporary on-demand credentials that are automatically rotated and scoped only to the specific pod that needs them. It's a game changer. Now, what's really cool is how elegantly ARSA solves this whole problem. Let's just walk through it real quick. First, your pod says to Kubernetes, hey, I need an identity to talk to AWS. Kubernetes then gives that pod a special short-lived token. Think of it like a signed passport. Then, the AWS Security Token Service, or STS, sees this valid passport and exchanges it for temporary AWS credentials, kind of like a visa for a specific trip. And finally, your pod uses those temporary credentials to securely get what it needs from S3. The best part? No long-lived keys are ever exposed. Right. We've controlled who gets in, and we've managed how our apps talk to the outside world. Now it's time to reinforce the castle walls themselves, to really harden the underlying infrastructure of our EKS cluster. These three tactics you see here, they're basically non-negotiable. First, you have to keep your cluster and your nodes updated. Kubernetes releases security patches all the time, and falling behind is just like leaving a window wide open for an attacker. Second, enforce the principle of least privilege everywhere, and I mean everywhere. Not just for users, but for every single component. And third, if you don't absolutely need it, turn off public access to your Kubernetes API server. Just lock it down and force all traffic through your private network. Now, inside the cluster, we need to set some ground rules for what our applications are allowed to do. Pod security standards are a built-in Kubernetes feature that acts like a rulebook for your pods. It helps you prevent really risky configurations, like allowing containers to run as the root user or to mount sensitive files from the host machine. It's all about making secure the easy default option. And let's talk about isolation for a second. By default, in Kubernetes, any pod can talk to any other pod. From a security perspective, that's not great. Network policies are the answer. Think of them as internal firewalls that you place between your pods. You can create rules that say the front-end service is only allowed to talk to the back-end API and only on this specific port and nothing else. This is absolutely critical for containing the blast radius if one of your components ever gets compromised. Whew, we have covered a lot of ground, from the outer gates to the inner walls of our castle. So let's pull all of this together into a simple, actionable blueprint that you can apply to every single EKS cluster you manage. Here it is, your 5-point checklist for EKS security. Number 1, tightly scope your IAM and RBAC permissions. No giving out overly broad access. 2, use IRSA for everything. Make static keys a thing of the past. 3, stay up to date. Patch your clusters and nodes all the time. 4, isolate your workloads with network policies. And 5, lock down that API endpoint. If you follow these 5 principles, you will be well on your way to a truly hardened, secure cluster. So as we wrap this up, the final question is really for you. Looking at this checklist and thinking about your own environments, what's the very first, most impactful step you are going to take to harden your cluster? Because remember, security isn't a one-time project, it's a continuous practice.